Hi everybody. In this section, we begin our discussion on triangles. Go ahead and write the title down, put the date, and then when you are done with that, unpause the video. So what we're looking at are types of triangles, classification. We can classify them by angles, and then we'll see another way to classify them in a minute. So this is all on page 12 in your book, and you can look at the e-book version, or if you have a physical book, you can look at that. What we are looking at are three different types of triangles. Acute triangles, like this first one right here, is considered acute because all of the angles are less than 90. And you don't have to write these down. They're available in your book. If you do want to copy them into your notes, the acute ones are all going to be angles that are less than 90. The next one we will work with a bunch in this class is the right triangle. And the right triangle obviously has a right angle, and that's why it's called the right triangle. One right angle. The third thing that you're looking at will be an obtuse angle, and that makes an obtuse triangle. And you have one angle that's greater than 90, and so then the other ones here would be all acute. So notice again, this one is equal to 90, so these are acute. So there will be some questions in the assignment about, can you have more than one right angle in a triangle? And kind of look at this picture and think about that. If a triangle adds up to 180, could you subtract 90 and then have an additional 90 left to split amongst two angles? So kind of ponder that thought, and that will be a question that comes up in the assignment. Another way that you can classify triangles is using sides. And again, this is on page 12 in your book. It's right below the other one. So if you look at the angles, you'll see the sides. So if you have all sides are equal in a triangle, and you could see this by the markings that are being used here, then what you have is an equilateral triangle. All sides are equal, equilateral. If you have two sides equal, then you have an isosceles triangle. Two sides equal, the third is not. And then if no sides are equal, you have a scalene triangle. One other thing that I want to point out is if you have an equilateral triangle, all of your angles in here are equal as well. So if you think about it, if there's 180 degrees in a triangle and you split it up equally, divide by 3, then each of those angles would equal 60. And again, you don't necessarily have to write this down, but you can if you want. Okay, the next thing would be the two sides equal. So in this case, these two lower angles would be congruent. Those sides opposite those equal, the angles opposite the equal sides. And then in this triangle, none of your angles will be the same. So another idea that you'll see is similar triangles. So if you have similar triangles, then you have corresponding angles that are the same and corresponding sides that are proportional. And I'll show you an example of that in a moment. So if you take a look at this figure here, these two figures, these are similar triangles. And you don't have to write any of this down. Just take a look at it. It says triangles DEF and GHI are similar. DEF, GHI are similar. Find the measures of angle G and I. Okay, so you can just kind of quickly look at it. D and G are matching. So you'd see that if this is 53, this one's 53. And also F and I are matching. So you can easily see that these would be called similar triangles because their angles are congruent and then their sides are also proportional. So you could set up a proportion to solve the sides. So take a minute to copy down this example, and you're going to write the directions. It says find unknown angle measures in each pair of similar triangles and the missing sides. So draw the triangles, pause the video so that you can copy this one down into your notes. Let's start out by finding the missing angles. So in this class, in order to write a missing angle, you just need to find out which ones are sitting in similar positions, the corresponding. So if angle A is 42, then find the one that is the same. So if you look over here, angle Q would match with that. So that would also be 42 degrees. let's look at these right angles. So angle C is just equal to 90, and so is angle P. Okay, and then finally, angle B and R. So those are not provided. So what you're going to have to do is use the fact that a triangle adds up to 180, and you could subtract out what's given. So in this triangle, we know that there is a 90-degree angle and a 42-degree angle. So go ahead and subtract those out to get that missing angle. To find the missing sides, you're going to set up a proportion. So you've got to kind of find the corresponding sides, the ones that are sitting in the same position. So if I say that AC, this angle up here and the right angle down there would match up with this side, and let's see, this side, let's see, I know this side matches with this one, then I could go ahead and set up a proportion. So there's lots of different ways you could do this, lots of combinations. I'm just going to start with the x over the 8. I'm going to find x first, which is side AC. So I'm setting up a proportion. X over 8, those two match. And then I'm going to use the other two sides that have actual numbers. I don't want to use 15 and y yet because I'm missing a number here, and that would give me two unknowns. So if I do x over 8, then I can do 9 over 6. Again, there's lots of different ways you could do it. You could say x over 9 and 8 over 6. You could have said 8 over x and 6 over 9. Again, it doesn't matter as long as you're being consistent. Okay, so now go ahead and cross multiply. And you can divide. Okay, and then 12 is side AC, so you could label it here. And then finally, QR, you're going to set up similarly. Now we can add in the 12 here. And you can set up another proportion. So I'm just going to go with the y over the 15. And then you can either do y over 15, 6 over 9, or now you could use 8 over 12. It doesn't matter as long as you're being proportional. So I'm just going to stick with given, y over 15, 6 over 9. If you start rounding and stuff, then you have the opportunity to make rounding errors or have a little bit of a different answer. So I always go with given information whenever possible. Okay, so I'm multiplying the 6 times the 15. So then y equals 10. So these are the assignment questions for this section, and let's take a look at number 26. The directions for number 26 says, classify each triangle as acute, right, or obtuse, and then classify as equilateral, isosceles, or scalene. Okay, so first of all, let's look at the angles. So think about whether this is acute, right, or obtuse. And if you look at it, I don't see any angles that are equal to 90 degrees. But the one thing I'm noticing is that right here, I have an angle that's equal to 120. So that would mean this is an obtuse triangle. Okay, the other thing I want to do is classify by the sides. You'll notice that all three of these sides are different, so that would be scalene. Okay, this last example that I'm going to do with you, number 42, says, name. Okay, so I'm going to find the corresponding sides and angles of these two given triangles. And again, you can look at the book to see it better. So I'm just going to list out first the angles. You can either write a capital letter or you can write the little angle symbol. It's really up to you. So I'm going to go ahead and, okay, so the congruent angles are B and Q. The other congruent angles are A and P. And lastly, you've got C and R. As far as the sides go, you're going to match them up in order. So AB, PQ, you could say BA, QP, whatever. Just make sure you're going in the same direction. So if I write AB first, then you need to make sure that you write PQ second. So just make sure you're going in that same order. So AB is corresponding with PQ. Okay, if I say CA, again, it doesn't matter which order you say first, just make sure you do the corresponding one the same. So CA and RP. And then finally, BC and QR. BC, QR.